A binomial is a two-term thing here. Binomial meaning two. It's a two-term expression. Usually when we think about binomials, this is like the generic form. There's all sorts of goofy ones, but we usually think of something like this. X plus 2, or maybe y minus 3, or maybe b plus 6. And maybe you could get a little more complicated and get like 3m plus 4. Or quite possibly, I don't know, t minus 8. Or 3x minus 22. Those are called binomials because they're two-term things. Usually the binomial has the first term as whatever letter, and the second term is 2 there. Are you with me? Now, what we're going to work on today, and it's kind of a whole big thing in math, is multiplying binomials. In other words, if I have x plus 2 and I am multiplying that by x minus 3, okay, how do I multiply those? Well, I'm going to give you the hard kind of-ish way, and then I'm going to throw at you the way that math books tell you to do it. Okay? Basically, all you're doing, and when you multiply binomials, is this: is you need to multiply every term of the first binomial has to get multiplied by every term of the second. I guess I should have put multiply here. Multiply every term of the first binomial by every term of the second. Okay. In other words, this. You're going to take this first term of this first binomial, and you need to multiply it by both of these. It's like expanding twice is really what you're doing. Okay? So I'm going to take x times x, which gives me x squared. I'm going to take x times a negative 3, which is negative 3x. And then I have to go do the other one. I have to take the 2 and multiply it by both terms of the second binomial. 2 times x is 2x, and 2 times a negative 3 is negative 6. And then you need to simplify. What terms actually combine? These two middle ones will combine to give you a negative 3 and a positive 2 is a negative 1, but we don't have to put the negative there. We have an x squared minus an x minus a 6. This is your answer when you multiply those two binomials together, which is what we call a trinomial. 3 terms. Not done with that just yet. Alex?
Will they ever make us do like binomials?
It could. And the same rule applies. You can always use this thing. Charlie?
I just get an X.
What?
I just get an X.
Because I have 2 x's and I take 3 of them away. That leaves me with 1 minus x. Josh?
After the x squared, where'd you get the 3x and then the plus the 2x?
X times x is x squared. X times negative 3 is negative 3x. Then I go to the 2. 2 times x is 2x. 2 times negative 3 is negative 6. Every term of the first one got multiplied by every term of the second one. And that works, you could have a 6-term expression times another 6-term, you do the same thing. Every term of the first one has to get multiplied by every term of the second one. That would still work for that. Now with binomials, math people, math books want you to remember this, and you'll hear this, and don't say why do we do this, because they do. They will talk about using FOIL. And what it stands for is this. It's a simple little acronym. It stands for first, outside, inside, and last, which means this. When you multiply binomials together, if you just follow this, it's really the same thing that we just did, just a little different way of thinking about it. You need to multiply the two first terms together, first term and first term, which gives you x squared. You need to multiply the two outside terms together, which is x and 8, outside, outside, which is 8x. You need to multiply the two inside terms together, which is 3x times x. And you multiply the two last terms together, which is 8 times 3, 24. It's the same thing we just did, but they will tell you to think about it in terms of FOIL. Because usually when you multiply binomials together, what's going to happen is these two terms are two that are going to combine. You will always be able to put these together. In other words, the middle terms always seem like they end up being like terms. So I can put 8x plus another 3x's, and I end up with 11x's. As a matter of fact, children, if you think about it this way here, your ultimate goal is to be able to do this actually mentally. Because if you think in terms of it doing this way, it really kind of comes together nicely. For example, if I have x minus 4 times x plus 5, I can tell you right now the answer to that is x squared plus x minus 20. If you think in terms of FOIL, it's not that hard, because your first term is always going to be what you get when you multiply the two first things together, which is x squared. You are going to end up combining the two outsides and the insides. You have a 5x and a minus 4x, which gives you 5x's, take away 4 of them, just an x. And your last term comes from the last thing multiplied together, which is minus 20. Now, that, again, if you can always do it, write it out, but their ultimate goal is for you to be able to look at that and go, oh, okay, I do the first terms, I put the outsides and the insides together, and then my last term is the last two multiplied together. Taylor?
I understand how you got x squared and how you got minus 20, but how did you get the plus x?
Alright, the plus x, and that's always where people go, that's where always people have trouble. The middle term comes from these two. The two outside times themselves, which is 5 times x. And the two inside, what's minus 4 times x? If you have 5 x's and you take 4 of them away, you're left with 1x.
So what could you put 1x there? So
You could, we just don't know that. For the same reason I didn't put 1x squared there. You have 1, it's 1. I can tell it's getting good here. X minus 3 times x, times x minus 2. Again, if you can see that, the answer to that is x squared minus 5x plus 6. Why? Because of FOIL. My first term comes from, what do I get when I multiply the two first terms together? If I combine the outers and the inners, the outside ones give me minus 2x, The other one's going to be minus 3x for a total of minus 5x's. Minus 3 to minus 2 to minus 5. And the last term comes from the two last times themselves, which is plus 6. Did I say that? And you can always say rat spoils again. Now, it does get a little bit more complicated. Where did I get 6 from? Charlie, it's 3 times 2.
I think I got this.
Write this one in your notes. And I would like everybody to pause, take 2 deep breaths. Because I'm going to tell you that at least 6 of you, when given this problem on a quiz, are going to say the answer to that is x squared plus 9. Okay? And it's not. Okay? Because of this. Anytime you see something like this, you should always write it out. It's a binomial times a binomial, in which case you want to use FOIL. When you use FOIL, your first term is x times x is. What do I get when I combine my outside terms and my inside terms? 3x and 3x is 6x. And then the last 2 terms are 3 times 3 is 9. Yes, there was an x squared and a 9, but you missed the middle term because in FOIL you come up with that one. 3 x's and another 3 x's is 6 x's. This term, children, this term always comes from the combination of the outside 2 and the inside 2. Put those together, you're going to get that. Everything else is easy because this is only. Well, because I multiplied them first, Charlie. I got my 3x when I multiplied these. I got my other 3x when I multiplied them, and then yes, I added them because they were like terms. Taylor!
The first ones that we did where we didn't do the FOIL thing, we do FOIL on those.
Yeah.
Oh.
I was just showing you what really FOIL, it's really the same thing.
Oh.
When you do FOIL, I just did it, same thing. Okay, I turned this and this and this. I'm even doing it in really the same order. Kendall?
For the 6x and x squared, why can't you combine those?
Because their x squares are not the same as x's. They have to be letters to the same exponents. You can't. That's multiplying.
You give it to me.
I will give you plenty to do. X minus 4 times x plus 6. You should have it done by now, by the way. And the proverbial survey says, Sam,
X squared plus 2x minus 2.
x squared plus 2x minus 20.
Yes, I got it.
I got x squared plus 10x. I just added 6 and 4.
Two first terms,
X squared. X squared.
the outsides and the inside. 6x minus 4x.
Oh, minus.
Positive 6.
Wait.
Here's a good one for you. X minus 8 times x plus 8. It's all good except the plus 64 part.
Minus 64. That's what I got.
What you will notice there, children, this is kind of a special case one. If your binomials are exactly alike except for one's a minus, one's a plus,
Oh, exactly.
the middle term is going to drop out because they're going to be exactly opposites. In other words, when you do this out, your first term is x squared, your outside term is plus 8x, and your inside term is minus 8x. Putting those together, it goes away because they're opposites. And then your last term is a minus 64.
That's what I got. Then I did
Now, the reason why it's important to think of FOIL, children, is because along the way this year, you are actually going to be given the trinomial, and you're going to have to work your way back to what two binomials gave you the answer. So you're going to have to do it backwards.
Let's not focus on that right now.
Yeah.
We're not focusing on